This is Unit 10, Lesson 1. This lesson is on surface area. We will be covering the surface area of a prism, a cylinder, a pyramid, a cone, and a sphere. Surface area is just the outside covering of a solid figure. So everything we're going to be looking at in this lesson is going to be a 3D shape. I'll call them solids, I'll call them figures, I'll go back and forth. And what we're going to be looking for is we're going to be looking for that outside covering. If you want to think about it in everyday terms, it's just the wrapping paper that we use to wrap our Christmas gifts in. That's what our surface area is. So when we calculate surface area, we would be calculating how much wrapping paper we needed to wrap that box. So the first thing we want to look at are prisms. Prisms are pretty basic. They're pretty simple. They're something that you've seen before. And hopefully, once you really understand how to identify what kind of prism it is, this will be really simple. The problem that most people seem to have with surface area and volume also is identifying what the figure is and then identifying all of the different numbers, because there are a lot of different numbers in the formula when you are solving for surface area and volume. So we're going to try and break that down into little pieces and make it as simple as possible. So the surface area formula, there's kind of like just one big generic formula that works for prisms. It works for any shaped prism, whether it's a rectangular prism, a triangular prism, a pentagonal prism. It's the same surface area formula all the way. It's what we use for prisms. It's what we use for cylinders. So that formula is surface area equals L plus 2 times B. The capital L is probably the only thing that's going to be new to you. Capital L means the lateral surface area. So lateral area of a three-dimensional solid is the space, it's all of the faces that connect the two ends of the figure to one another. So if we use this rectangular prism right here in example number 1 to talk about lateral surface area, first thing you want to do is you want to identify your bases. Your bases are two shapes that are exactly the same, that are parallel to one another. Keep that in mind, they have to be parallel. With a rectangular prism, you can kind of pick and choose what you want to call your bases. A lot of the times people want to call the piece, the side that the figure sits on, the base, because that's how they think of the word base, is it's what you sit on. But, so you could use the top and the bottom as your bases, but I like to use the things with the smallest numbers if I can, because I'm going to need to use these numbers more than once. And so if I can keep those numbers small, it makes my life a little bit easier. So I identify the bases of this figure as the two squares on the end. So that means the lateral area are all the faces that wrap around the figure and connect those two bases to one another. So we have to calculate that lateral area. And then we have to add to that the area of the two bases. So the 2 indicates that there are two bases. And this capital B is the area of that base. So when we do this, we're going to calculate the lateral area, and then we're going to calculate the area of one of these squares, and we're going to multiply it times 2 because there's 2 of them. The best thing you can do is simplify this, even though it won't look simplified when I get done with it. You're actually going to simplify it by substituting in the formula for lateral area and substituting in the formula for the area of the base. So that's what we're going to do first. We're going to substitute those things in. The nice thing about prisms, no matter whether they're triangular or rectangular or hexagonal, is that the formula for the lateral area is always the same. It's always the perimeter of the base times the height of the figure. This is not how tall the side of a triangle is, and we'll talk about that more in the second example. This height is how far the two bases are from one another. It's the distance between the bases. So here we would look at this base, and the height would be the distance between the two bases. It doesn't necessarily mean how tall the figure is. It just means the distance between the bases. So we'll calculate the perimeter of the lateral of the base, and we'll multiply that times the height of the solid. And then we'll add 2 times length times width, because the formula for the area of a rectangle or a square is length times width. So then that's our simplified formula. As odd as that sounds, even though it doesn't look simplified, it is simplified because it's breaking it down into every individual number that we need. So let's identify those numbers. We need to find the number that is the perimeter of the base. We need to find the number that is the height of the figure. We need to find the number that's the length of the side of the base, and we need the width of the base. So the perimeter of the base means we come down here to this square on the end, and we just want to add those numbers up. And even though there's not a 5 and a 5, you recognize that this is a square, so you know that this is 5 inches and this is 5 inches. So we're going to add 5 plus 5 plus 5 plus 5. And when we add those things together, we know that all those 5s equal 20. So the perimeter of the base is 20. The distance between the two bases is 18 inches. And then we do the numbers that are the area of the base. The length of the base is 5. The width of the base is 5. It's a nice thing about squares. All the numbers are the same. And then we're going to take these numbers and we're going to substitute them into this formula right here. So surface area equals the perimeter of the base, which is 20, times the height of the figure, which is 18, plus 2 times the length of the base, which is 5, times the width of the base, which is also 5. Now, the nice thing about formulas that you're going to see throughout surface area and volume is that the majority of the time, if you're just looking to calculate the surface area or the volume, all you need to do is type that string of numbers into your calculator. And I would much rather you type them in your calculator than try to solve them piece by piece on your own. Because I've noticed recently that a lot of people are not following order of operations, and you have to follow order of operations if you're going to do everything by hand. And I'm getting people that are multiplying different pieces together at different times and adding across before they multiply, and I'm getting some weird answers. So when I plug all of this into my calculator, I find that the surface area of this rectangular prism is 410. This prism has been measured in inches, so it's inches squared. We're talking about area, and area is squared because it's a flat surface. So even though this is a three-dimensional figure, we're still talking about the outside surface of it. We're not talking about filling it up. So we multiplied a length and a width together to find that area. So the surface area of this rectangular prism is 410 inches squared. Now, a prism can have different shapes depending on the bases. So in this figure, you want to look for bases, you want to look for things that are parallel to one another. You want to look for shapes that are parallel to one another. A lot of the times people's first reaction is to go, well, it's sitting on this rectangular side, so it's a rectangular prism. Yeah, it's sitting on that rectangular side, but is there another rectangle that's parallel to that one? Not in this figure. In this case, my parallel sides, I have one side here that's a triangle, and it's parallel to this triangle back here. And if you'll notice, right back here, this is marked as a 90-degree angle. So it is a right triangular prism. So our bases in this one are triangles, so this is a triangular prism. So when we go in and we rewrite that formula that says surface area is the lateral area plus 2 times the area of the base, we have to take into account that now that capital B is going to deal with the fact that we have triangles on either end. So we're going to go substitute in the appropriate formulas to kind of expand this one out so that we know where all of our numbers need to go. Lateral surface area of a prism is still the perimeter of the base times the height of the figure plus 2 times, now the area of the base. Well, the base is a triangle, so we need to use the formula for the area of a triangle, which is 1/2 little b base times h. So now we've got letters that have started to repeat, so we've got to be careful and make sure we keep all those things organized. So let's start with the perimeter of our base. So our base is a triangle. One side is 3.6. One side is 4.8. And the third side is labeled way back here at the end. That's 6. When I add 3.6, 4.8, and 6 together, I find that the perimeter of the base is 14.4 inches. So capital P is 14.4. Now this H goes with the perimeter of the base. So that means this H represents the distance between the two triangles. So the distance between these two triangles is 8.5 inches. So this H is 8.5. And I put brackets here with this P and this H so I know that these two go together. So when I go to plug these numbers in, substitute them into the formula, I know to substitute these two numbers in right here. And then I need to find the base of the triangle and I need to find the height of the triangle. So this B and this H refer just to the triangle on the end of the figure. Now, the nice thing about a right triangle is that when we look for the base and the height, we look for that 90-degree angle, and those two legs are the base and the height. Kind of like length and width in a rectangle, it doesn't matter which one's the base and which one's the height. We just want to put them in. Now, if you don't have a right triangle and you're looking for the base and the height, remember you have to have a perpendicular line, and that will usually be drawn. So if you have a triangle kind of like this, they'll draw the height in. They'll give you a dotted line and a right angle. And so then you'll know that this is how tall your triangle is, and this is the base that you want to use, because there's your 90-degree angle, and you look for two sides that meet at a 90-degree angle to find your base and your height. So the height of our triangle now is 4.8. So we're going to take these numbers, and I'm going to put a bracket here so that I know this base and height go together when I put them in this formula. So we're going to take all four of these numbers and we're going to plug them in to this expanded formula that we wrote. So surface area equals the perimeter of the base times the height of the figure plus 2 times, and now we need to calculate 1/2 times 3.6 times 4.8, because those are the numbers that represent our triangular base there. So we're going to plug all that into our calculator. 14.4 times 8.5 plus 2 times, and instead of putting in a fraction, you can put the fraction in if you want to. I'm just kind of lazy. I'm going to change that fraction to the decimal 0.5 times 3.6 times 4.8. And so I find that the surface area of this rectangular or this triangular prism is 139.68, because our directions say round to the nearest hundredth, and it's measured in inches and its area, so it's squared. So the surface area of that triangular prism is 139.68 inches squared. Now, the third figure we want to look at is a cylinder. We put the cylinder with the triangular and the rectangular prism because it has the same generic surface area formula. But instead of having flat triangular sides or flat rectangular sides that connect the ends, it has a curved surface, and we have to use numbers and we have to use pi and all that stuff that goes with circles. So we want to find the surface area of this cylinder, and we're going to round to the nearest hundredth. Here's where you want to make sure you know where to round, because we're using pi, we're going to get some longer decimal numbers. So the first thing we're going to do is we're going to take that lateral area plus 2 times the area of the base, and we're going to expand that into a simpler formula, simpler because we can identify all of the individual pieces needed to make that lateral area and the area of that base. So our new formula, so for the surface area of a circle or of a cylinder, we need to use pi and radius because we're looking at the distance around. So that's still, think 2 pi r is the circumference of a circle. So that's still the perimeter of the base, and this h is still the height of the solid. So this h is still going to be the distance between those two circles on the end. So this is going to be 2 pi radius times height plus 2 times, and then we're going to use the formula for the area of a circle, and the area of a circle is pi r squared. The nice thing about cylinders is that there's a lot fewer things to identify. We need to identify the radius, and we need to identify the height of the figure. So when we look at this particular cylinder, our radius is 3 centimeters. Remember, the radius only goes halfway. So the radius goes from the center of the circle to the outside edge of the circle. So my radius is 3, and this h, because it's the distance between the two circles, is 9, because from the top circle to the bottom circle is 9 centimeters. And then we're going to take these two numbers and we're going to substitute them in. Surface area equals 2 pi. We're going to put 3, because that's our radius, times 9, because that's our height, plus 2 times pi times our radius 3 squared. The only thing that should get squared is the radius. Don't square the whole thing. Don't square the pi. Don't square the 2. Square the radius. And now you really want to be able to use that calculator because that's a nice big long formula. And it uses pi, and we're going to use the pi button. I'm not going to use 3.14. Sometimes just to keep it from giving me long decimals, I'll use the 3.14 instead of the pi button. But the most exact answer you can get is using the pi button. So I'm going to put all of this in going all the way across. So I'm going to say 2 times pi. And if you can't find pi, it's right here above the caret button, and it's in blue, so you need to hit the second button. So second caret button. So 2 times pi times 3 times 9. Notice, when I put this in the calculator, you can put multiplication signs between numbers and pi, but if you don't, the calculator knows that that just means you need to multiply times pi. And then we're going to say plus 2 times pi again, and this time we're going to say 3 squared. And I'm going to put that in parentheses just so that I can visually see that the only thing I've squared is the 3. When I hit enter, get a big long decimal, but remember my direction said round to the nearest hundredth. So my surface area is 226.19. My cylinder was measured in centimeters, so it's centimeters squared. So those first 3 figures use the generic formula, surface area equals lateral area plus 2 times the base. So we kind of lumped those all together because they use the same generic kind of formula. Then we have spheres thrown in there, and pyramids and cones. Well, those don't fit with prisms, and spheres don't fit with pyramids and cones. So we're just going to do a sphere all by itself here for a second. You need to know the formula for a sphere. The surface area of a sphere is surface area equals 4 times pi times radius squared. No lateral surface areas, no bases that you got to know. You just got to know that because it's a big circle, and this tells us, this problem says, a spherical water tank has a diameter of 21.5 feet. The corrosion-resistant alloy skin of the tank is 1/8 of an inch thick. How much alloy will it take to make the skin of the tank rounded to the nearest square inch? So, let's see. We need to, because a spherical water tank is a sphere, it's a big giant ball. We're going to use the formula surface area equals 4 times pi times r squared. So we need to identify the radius. That's the only number that we need, because 4 pi is just 4 pi. So this tells me that the diameter is 21.5 feet. The diameter and the radius are not the same thing. The diameter goes all the way across the circle, all the way across the sphere. I need the radius that goes from the center to the outside edge. So I'm going to take that 21.5 and I'm going to divide by 2. I'm going to cut it in half because my radius only goes halfway. So 21.5 divided by 2 is 10.75. And then I'm going to plug this number in. So surface area equals 4 pi times 10.75 squared. And then I'll put that whole thing in my calculator. 4 pi times 10.75 squared. 4 pi, parentheses, 10.75 squared. So I find that the surface area, the amount of alloy that is going to be needed to make the skin of this tank, just the surface area of it, is 1,452.20, and it's inches. So and it said round to the nearest inch. So I'm going to need 1,452 square inches of corrosion-resistant alloy to cover that spherical water tank. Now the last 2 figures we want to look at are pyramids and cones. Pyramids and cones are similar to one another in the way that prisms and cylinders were similar to one another. It's all about the base of the figure. So we use the same generic formula for all pyramids and cones. We use surface area is the lateral area plus the area of the base. The only difference between the prism formula and the pyramid formula is that the pyramid formula only uses one area of the base because there's only one base. And then we've got a different lateral area formula. The formula for the lateral area of a pyramid is a little bit different too, because those things don't all just come up and connect another base. They come up to an apex, a point at the very top. Or if your pyramid's flipped upside down, they come to a point at the very bottom. Key is they all come together at the apex. So we want to first substitute in and expand. So we're going to say surface area equals lateral area plus the area of the base. So the formula for the surface area, the lateral surface area of a pyramid is 1/2 times the perimeter of the base times something called the slant height. The slant height is just the distance from the edge, from the base edge of the pyramid, up the side of the pyramid to the apex. It's not how tall the pyramid is, it's just the distance. Like if I was going to crawl from this side of the triangle all the way to the top of the pyramid, that would be the slant height. The slant is along the wall of the pyramid. So we do 1/2 because these are triangles. They're not rectangular in shape like they were with a prism. And then we're going to say plus the area of the base. Now this figure, so I've got all of these coming up to a point at the apex. So that means that this side right here has to be my base. This is a triangular pyramid because this base down here is a triangle. That's how it gets its name, triangular pyramid. So to do the area of the base, we have to do that 1/2, the base of the triangle times the height of the triangle. So let's identify all of our letters. We need to identify the value of the perimeter of the base of the triangle. We need to identify the slant height. The slant height, for some reason, is always written as kind of a cursive L, so I'll try to write it as a cursive L so that it doesn't get mixed up with the length and width of a rectangle. Then we're going to need the base of the triangle, and we're going to need the height of the triangle that is the base of the figure. So many words, so many uses for the word base today. So the the perimeter of this triangle is 9 centimeters on this side, 9 centimeters on this side, and 9 centimeters on that side. So 9 plus 9 plus 9, all those 9s, 9 plus 9 plus 9 is 27. So the perimeter of the base triangle is 27. The slant height, notice the slant height is this kind of even lighter line drawn along the outside edge. The slant height is 11.3 centimeters. And then we want to find, I'm going to erase this so it's a little easier to see. We want to find the base and the height of the triangle. This triangle that is the bottom of the pyramid, it's the base of the pyramid. This triangle is not a right triangle like our prism was in the other example. This is actually an equilateral triangle. So in order to find the height and the base, you need to look for a height that's been drawn in the triangle, and you need to look for that 90-degree angle that's been made. So this 7.8 centimeter line intersects the 9 centimeter side at a right angle. So this is my base. Actually, most people would call this your height because it's kind of how tall that triangle is. And this would be the base of that triangle. Doesn't really matter what order you put the numbers in because you're multiplying. So let's just kind of stick to what is the habit that we're all in. So the perimeter of the base and the slant height go together. The little b base and this height go together. So we're going to plug all these numbers in. The surface area equals 1/2 the perimeter of the base times the slant height of the pyramid plus 1/2 the base of the triangle times the height of the triangle. The box around that so we don't accidentally think it goes with our formula. And then I'm going to plug all of that in. Once again, I'm going to type in, instead of a fraction at 1/2, I'm going to type in 0.5. 0.5 times 27 times 11.3 plus 1/2 times 9 times 7.8. So the surface area of this triangular pyramid is 187.65 in its area, so it's centimeters squared. So if I wanted to wrap that up, I'd need at least 187.65 centimeters squared of wrapping paper. The next pyramid in your notes is a rectangular pyramid. I know it's a rectangular pyramid because the base, which is that side that all of the other lateral faces are coming to an apex above, that base is a rectangle. It could be a rectangle, it could be a square. I think in this case it's actually a square, so if you wanted to label these other sides as 5 inches, you can do that. So, because it's a rectangular pyramid, that's going to change our formula a little bit. So up here, we took it's going to still be surface area as lateral area plus the area of the base, but it's going to change a little bit because this capital B is now going to change based on the fact that the base of the pyramid is a square. So we're going to say the surface area is 1/2 the perimeter of the base times the slant height plus the length times the width. So length times width. If you want to make that a capital L so you can tell it's an L and not a 1, go right ahead. So let's identify the value of all of these. The perimeter of the base and the slant height, those two things are going to go together. So the perimeter of the base is 5 plus 5 plus 5 plus 5. We've done that before. That's 20 inches. So that's the perimeter of that rectangle at the bottom. And the slant height, remember the slant height lays on the side of the pyramid wall, and it goes from the base edge to the apex. The slant height is 9 inches. And then the length and the width are just the length and the width of the rectangle that is the base, so 5 and 5. So we're going to take these numbers and we're going to plug them into this formula that we rewrote. Surface area equals 1/2 the perimeter of the base times the height plus the area of the base. So 5 times 5. So 1/2 times 20 times 9 plus 5 times 5. Well, that came out nice and even. This pyramid has a surface area of 115 square inches. The last solid figure that we want to look at is a cone. And the cone is similar to the two pyramids that we just did because it has the same basic shape, only now the base is a circle. So when we do this, we're going to have to take into account everything is curved. And when things are curved, that's when we have to start using pi. So the lateral area plus the area of the base. So when we're doing the surface area of a cone, the lateral area, instead of being perimeter, is going to be that circumference formula, which is pi times radius, and then the slant height, plus the area of the base, and the area of the base or the formula for area of a circle is pi r squared. All right, so let's identify our variables. We need to find the radius, and we need to find the slant height. So the radius is right there, nice and clear, 6 centimeters. 6 centimeters. Now the slant height should be right there because it should be that outside edge of the cone. It should be the edge of the cone going all the way to the apex. Except that there's not anything there. There's just an L there saying, hey, this should be the slant height. But you know how to calculate this. Notice, we know the height of the cone. We know from the center of the cone to the apex of the cone, we know that it's 8 centimeters tall. And we know from the center of the cone to the outside edge of the cone is 6 centimeters. And those two lines make a 90-degree angle. So what do you have? When you have a 90-degree angle, you've got two legs and you've got a hypotenuse. You've got a right triangle. You know how to work with right triangles. That's what we've been doing. Now the nice thing is this is a simple right triangle, and the only thing you need is the Pythagorean theorem. A squared plus b squared equals c squared. So remember, A and B are our legs, so that would mean that these two things are our legs, and the hypotenuse, remember the hypotenuse is opposite the 90-degree angle, so that's my C. So my slant height squared equals 8 squared plus 6 squared. And 8 squared plus 6 squared actually equals 100. So my slant height squared is 100. That's not my slant height. I need to do the square root in order to find my slant height. So my slant height is 10. Just because you're missing a number when you go to work on a problem doesn't mean you can't solve the problem. There is almost always some way for you to find that missing piece of information. In geometry, it's all very, very tied together, and so you're going to have to use all of the things that you know about circles and triangles and rectangles in order to make geometry work for you. So then we're going to take these two numbers and we're going to plug them back into that expanded formula. Surface area equals pi. Instead of an r, we're going to put a 6. Instead of an L, we're going to put a 10. Plus pi times, put that 6 in there again, and we're going to square it. Remember, we're going to use the pi button, so second caret gets us the pi button. Pi times 6 times 10 plus pi times 6 squared. So our surface area of this cone is 301.59 because our instructions say round to the nearest hundredth. It's measured in centimeters, so it's centimeters squared because we're looking at area. Now, that's a lot of formulas and a lot of little bitty pieces to keep track of. So at the end of your notes, we've just kind of consolidated all of that. So, general formula for a prism and what it looks like in the expanded forms that we've used. General formula for a pyramid and a cone and the expanded forms that we've used. And then spheres because they're just thrown in there for good measure.